All right, so there are two reports that you need to give me. Yeah, so for practical 4, which is today's one, and practical 5. So these two will be marked. Yeah, so this week and also the week after next. Okay, so practical 4 and practical 5, you need to hand me the report. The report is very, very simple. The format later I will go through. So looking over here is in total 25%. Okay, in total 25%, and here is how I rate your reports here. Okay, so the this is the marking rubric. If you did a very good job, okay, like for example, reports illustrates an accurate and thorough understanding of the scientific concept underlying the labs, then you get excellent. Okay, so if you do under the report illustrate an accurate understanding of most scientific concept underlying, okay, most, then it's good. If limited understanding, then it's fair and so forth. Okay, but I think if you have understand the lab, usually is either good or excellent. Okay, depending on how you write it. Yeah, depending on how you write it. Okay, should be either good or excellent. Yeah. Okay, fair is like totally you don't care about the lab report. Okay, then you may get fair. Yeah, but usually students will get good or excellent. Yeah. Okay, and you should submit the two practicals. Okay, the 3 and 4. No, not 3 and 4. 4 and 5. Okay, you should submit 4 and 5 by the week 12, 13th of November. Yeah, 2020. How you submit, right, is that you need to scan it. Okay, if you don't have a scanner at home, then you can use the OneDrive app to scan the practical 3 and 4. Actually, right here 1 and 2. Yeah, it's error. Okay, 3 and 4 into the one label. Okay, one file. Okay, then you submit together. So today's one, you wait, not wait as in not wait to combine. Okay, just do it. Okay, you do your practical report first. Then after that, you wait until the next one you do together. You scan into one file, and all right. So here you see. So over here, practical 1 and 2, the data is here, but today we go through practical, the first one first. Okay, then the second one, then we will wait until the week after next, only we will do, yeah. So for the practical reports, is very, very simple. So over here. Now there you go. So today's practical we're going to talk about is this functional group 1. Okay, functional group 1, which include the hydrocarbon and alcohol. Okay, so alcohol, I think we will be covering this week. Alcohol actually we covered already. Okay. Okay, so practical 4, chemistry or functional group. So for the practical report, is very, very simple. Okay, I will be giving you all the observation data. So what you need to do, right, is you go into this, you need to complete your pre-lab questions. Basically, you need to understand your molecule first. So I want you to draw out the expanded molecular structure over here. So how does it look like? Okay, cyclohexane, how does it look like? 1-butanol, Okay, how the structure look like, 2-butanol, how the structure look like, and 3-methyl 2-propanol, how it looks like. Because it's important for you to understand the structure first, because the reaction depending on the structure. Okay, depending on the structure. So over here, I have given you the data already. So basically, you need to write down the observation here, okay, for your report here. So for your report, you need to submit this one, okay. Then you need to submit together with this one. Of the observation data, just right over here. I've given you in the times module already. And from the observation data, I need you to find out what is unknown A, what is unknown B. Okay, what is unknown A, what is unknown B from the observation data. So unknown A, unknown B is either one, the hexane or cyclohexene. Okay, so based on the observation data, you should be able to know whether is it a hexene or cyclohexene. Okay, then you need to do a discussions. Okay, the marks will be given over here, especially the discussion on how the result is being concluded over here. Yeah. Okay. Okay, so how you conclude over here, how you find out what is unknown A, what is unknown B, okay, and what are some of the observations. Okay, same goes to C. All the observation data has been given. Okay, so the 3 alcohols, the unknown C, D, and E can be either one, the 1-butanol, 2-butanol, or 3-methyl 2-propanol. So this is more complex because each of these tests will only target a certain the functional groups here. So you need to look at the structure in order to determine what is what. So same thing, you need to write a discussion on how the result is being concluded to identify the unknowns here. Okay, so if you be able to discuss and describe, okay, how you come up with the conclusion, okay, the more detail, the better. The more details shows that you are able to understand and that how understand that how it is how the functional groups affects the test, okay, how the test actually can determine based on the functional groups, and then you give get the higher marks. Yeah, okay, maybe you'll get the excellent category. Okay, if you're looking at the marking rubrics. Okay, so very simple. Yeah, so you do this one, and then you wait for the practical 5. Same thing, practical 5. I will give you the observation data. Okay, I will give you the observation data. You need to draw all this out first. So all these two you need to draw out, okay, on your own. And then the observation data, okay, is given over here. All right. So from here, right, then you will get the marks. Yeah, together these two, you scan together into one file. Yeah, into one file. So for the practical report, you scan into one file for 4 and 5. Then you submit together before the week 12. Okay, 2nd November. All right. So 2nd November, you submit these two files here. Okay, any questions? Any questions? Okay, some people may ask me how do you submit. Okay, here is how you submit it. So now I'm sharing the times module here. The times module. Over here, do you see this? Submission of practical 1 and 2. Later I will change it to 4 and 5 here, okay, to make it less confused. Okay, you click over here, then you should be able to submit it. Okay, so you just click on this one. So this is a lecturer view, so I think you have to view on your own. Okay. All right, so you need to submit over here. Yeah, click on this one, this thing to submit. All right, maybe I'll right there, click here. Okay, submission, click here. So all these are the things that you need to submit. Yeah, okay, the instruction over here. Okay, any questions? Any questions? Okay, those who came late, yeah, I have just mentioned that you need to submit these two, practical 4 and 5, okay, into one file for submission for marking, yeah, because it will consist of 25% marks, yeah, okay, for these two. Okay, so later you can go through back the recording. Okay, sorry, a bit frozen. Okay. Okay, you need to submit, yeah, these two. So the data over here has been given. Okay, you just need to write down the observation, the discussion, as well as do the pre-lab and submit all together in one file. Yeah, submit all practical 4 and 5 in one file for the marking. Okay, and how you submit, you just click over here. Yeah. Okay, any questions from the other students? Any questions?
No, Dr. Ben.
No, yeah, very clear. Yeah. Okay. Okay. Nick, remind me to discuss on the next assignment, yeah, for organic chemistry. Yeah.
Okay, Dr. Ben.
Okay, which is the poster presentation.
Okay.
Okay. Okay, let's go through the practical. Where is it? Sharing. Okay, let's come to this practical for functional group 1. Instead of going to the lab to do the experiment, so I just need to show you why and how and what sort of observation you should be able to see. Yeah. So today's we're going to concentrate based on the hydrocarbons, okay, alkenes, and alkynes, okay. But we're going to use the alkene and alkyne is very, very similar. So we will just use alkenes only as an example. So for the first part, 2 hydrocarbons has been selected, okay, for tests. Okay, there will be 2 tests for these hydrocarbons, and based on the observation, you should be able to identify who is and which is which. Yeah, so you got hexane and cyclohexene. Okay, you got hexane and cyclohexene. One of these will be unknown A, one will be unknown B. So in the lab, you will see these 2 chemicals labeled as unknown A and unknown B. Then you'll be doing the test. Then after that, you should be able to see the observed data. Then you can identify whether this is unknown A, is it a hexane or cyclohexene? Unknown B, whether it's a hexane or cyclohexene. Yeah. So these 2 is different in terms that one of them, hexane, doesn't have any of the double bond. Okay. So the reactivity is quite limited, all right, other than the combustions. For the cyclohexene, okay, because it's the hexene, there's a double bond. So it can be reacted because of the double bond, it can be reacted, and also it can be have the addition reaction, which means that something can add into it. All right. So the first step that we're going to do is basically reaction with the bromine solution. Okay. So bromine itself is actually a bit reddish color. Okay, something similar to this. All right, so bromine solution is reddish in nature, which is look exactly like that. So if you add it to a double bond, okay, or alkene or alkyne, what happened, right, is that the bromine, okay, the bromine which is supposedly attached to each other, they broke it. Okay, they broke it, and the Br add to one carbon, and the other Br add to the other carbon, and reduce it um, to become a single bond. Actually, the reason why it loses its color is because the bromine has broken it. Okay, the Br2 has been broken. So once it's broken already, then the color will no longer be displaced. The color only will be displaced when they are joined together. Okay, when they join together, then they can vibrate in a certain frequency, and then lead to the red color not be able to be absorbed, and we can observe the red color here. Whatever we observe here, if it's red color, means that the color is not being absorbed. Other color has been absorbed other than the red color. That's why we can see red color, yeah. So when the Br add to the double bond, and the bromine loses is the red color, that's why you can see that it's clear. So this is the positive test. Okay, positive test is display the ability of the alkene to reduce the bromine solution, not really reduce, the bromine can actually add to it, and then the color become colorless here. All right, so this is a negative test. Negative test usually is when there is a cannot be reacted, so the bromine solution cannot be reacted with the compound. Okay, in the case which is similar to the alkane, okay, alkane, then you add, it won't reduce. That's why you still present as a red brown color, yeah, red brown color of the bromine solutions. But of course, as I mentioned before, the more bromine solution you add in here, okay, when you add more and more and more until all alkenes has been utilized, okay, then the red color will start to display. So it's very important that this test you do not overload with too much of the bromine solution. Okay, so in this test you need to make sure that there is sufficient of the alkenes to actually reduce the bromine solution. All right, any questions? Oh yeah, okay, no question. Yes.
So what's actually the ration of alkane and bromine that had to be used?
It's a 1-to-1 ratio in this case.
1-to-1 ratio. Okay.
Yeah, so 1 molecule to 1 molecule of bromine.
Okay.
Yeah, so you can determine the molecular weights or the from the concentration. So you remember, have we done the concentration calculation? Not yet. Concentration 101, no, you don't have to calculate, but you can calculate from the molar mass. Remember we studied in chapter 1 and chapter 2 how to determine from the molar mass, right? Then you can determine how many moles. You should have at least 1-to-1 mole in it.
Okay, thank you, Dr. Ben.
Okay, so you can calculate from there. Okay, so you got the molar mass. From the molar mass, okay, then you can know how many grams you added in both. Okay, then from there, because molar mass is grams per mole, okay, it's grams per mole. So you know how many grams of your alkenes, you know how many grams of bromine you use, okay, then you know how much of the mole is in each. Okay, so you can calculate based on that. So you just say that you use 2 grams of the bromine solution, and then 2 grams of the hexene. Okay, see whether is it 1-to-1 ratio. If it's not 1-to-1 ratio, one is more than the other, then you need to reduce the amount of grams in there. Yeah. But usually a simple test, you can just do it, just drip in it. So normally you just drip in it, okay? Just use a dropper and drip in it. And the moment you see that the brown color disappeared, then you know that is actually is reducing the bromine, okay? It's very, very simple. This is more advanced, but the normal one, you just drip in it into the test tube. Then the moment it reduces, then you know that it's not an alkane, it's an alkene. Okay, the next one is the reaction with a concentrated sulfuric acid. Sulfuric acid is a strong acid, yeah. It's a very, very strong acid, right? So what happened, right, is that when it reacted with the double bond, okay, of with alkene, it actually can form this molecule, okay. This molecule is what we call the alkyl sulfonic acid, yeah. Okay, alkyl sulfonic acids. And this sulfonic acids, right, is soluble in the H2SO4, yeah. H2SO4 is actually contains this molecule in aqueous solution, yeah. All right, they diluted in the aqueous solutions. So you can see over there. Okay, if water in there, there should be a certain amount of water in there. All right, so it should be able to dissolve. If it's alkane, okay, if it's alkane, it cannot react. Okay, it cannot react with the strong sulfuric acid, so you cannot produce this. All right, in this case, right, if it's an alkane, since it cannot be reacted with the strong sulfuric acid, what does it mean? It cannot produce a soluble, alkyl sulfonic acid that is soluble in H2O2. In this case, you will see two layers. Okay, in this case, you will see two layers. The top layer will be the alkane. The bottom layer should be the H2SO4. Yeah. Okay, because of the density difference, that's why there is up and down. Okay, two reasons here. Two reasons. One reason is because it's not soluble in each other. Second is because of the density difference. Yes, density difference. That's why the alkanes have a lower density. That's why it will float on top of the H2SO4. Okay, so the alkane saturated hydrocarbons are reactive. For example, like alkane, okay, that I just described to you. Another one is the aromatic compounds. Okay, aromatic compounds with 1, 2, 3, 4, 5, 6 with a double single bond. Okay, this is the aromatic compounds. It's unreactive as well. Okay, any questions?
No, Dr. Ben.
No, yeah. Okay, another test. Another test is a reaction with the potassium permanganate. Yeah, potassium permanganate is KMnO4. Okay, basically it can oxidize the unsaturated compound to produce a diol compounds. Okay, so if it's with the hydrocarbons with a double bond like alkene, so what happens is that the alkene, they can react. Okay, they can react with the double bonds, and then they will produce this diol compound. So the KNO4 is purple color, look exactly like this. Okay, purple color. All right, but if it's reacted, what happens is that instead of seeing purple color, you see a brownish color. Okay, MnO4, because the potassium has been reacted. Okay, so after reacted, you will left back MnO2, and Mn2 is brown in color. All right, so if reacted, then it will display, instead of purple color, you display brown color, and this is how it looks like. Yeah, this is how it looks like, brownish color. Okay, this is how it looks like if it's reacted. If it's alkane cannot react, then you will see the negative test result, which is purple color. Okay, purple color. Okay. Any questions? Some of them, yeah, sometimes you observe the brown participates here, okay, depending on how much it has been formed, the manganese oxide. Sometimes if you have a lot formed, then you will see greater the brown precipitates. If it's a little bit, okay, then possible able to suspend inside the solution, yeah, like what you're seeing over here now, okay, how you're seeing over here now. Okay, clear? Okay,
Yeah.
yeah, clear. Okay. So you, with all this observation, understanding all this observation, then you can discuss. As I mentioned already, the discussion is very important based on your understanding in all this theory. Okay. So if you're able to understand the theory, then you're able to compare how you come up with the conclusion. Okay. And then you can get a higher mark based on how you write it. Yeah. Okay. Okay, the next test will be on the alcohols. Okay, 3 hydrocarbons will be tested. Okay, the 1 butanol, 2 butanol, and 3 methyl 2 propanol. Okay, so all these three, they are either so it won't be this one, yeah. Today we are not testing on the phenol. So it will be either a primary, a secondary alcohol, or a tertiary alcohol. And the reaction really based on this, yeah. That is why it's very important, right? That's why in the pre-lab, I asked you to draw the structure. Okay, in the pre-lab, I asked you to draw the structure. The purpose why you draw a structure is so that you can decide, or you can determine whether is it a primary alcohol, secondary alcohol, or tertiary alcohol. Okay, from that, then you can analyze from the test itself. Okay, from the test, you can analyze from the test. So the 1 butanol, 2 butanol, or 3 methyl 2 propanol, it will be labeled in the lab, right? You don't see that. It will be labeled as either an unknown C, unknown D, or unknown E. In the lab, you will see these three. So you need to do the test and find out what is what. Okay. So the R over here, you see the R over here, it means the it can be any of the groups here. Okay. So it can be like, for example, CH. Okay, let's draw one of these. Yeah, butanol. One butanol. Let's make it 2 butanol. Okay, 2 butanol. But is 4 carbon. Correct not? Okay, 4 carbon wood. Then the alcohol is located at carbon number 2. So the rest will be here. Sorry. So expanded structure, yeah. So you see over here, expanded structure. All right. So from here, you want to determine whether is it primary, secondary, or tertiary. You need to look at the carbon directly attached to the hydroxyl group, OH group. Okay. So in this case, is this a primary or secondary or tertiary alcohol? Sorry? I can't hear you. Hello?
Secondary.
Secondary, very good. Okay. So you can see from here, for two groups over here. Okay. So very clear. So here you see exactly like that for two groups over here. Okay. So two groups over here and the H over here. Okay. So this is a secondary alcohol. So your task, okay, I won't give you all the answer. The task, you will need to draw it out and determine whether it's a primary, secondary, or tertiary alcohol. Yeah. So the isotherm test, okay, the first test that we're going to test is using the isotherm test, okay. In this test, only alcohol with the metal group attached to the carbon bearing the OH. So whenever you see if there's a CH3 attached to it, then it can react with the isotherm reagent. Yeah. The isotherm is consists of the I2, the iodine, as well as the sodium hydroxide solution. Yeah. So this is what it means by the carbon attached. So you see over here, this is a carbon. I just move the H over here, make sure it's easy to see. Okay, so you see over here the carbon over here, carbon attached with a metal group. This is the metal group directly, yeah. Okay, directly attached to a metal group. So this compound can react with the isotherm the test. Okay, so if you react in such a way that they will form this isotherm the yellow precipitate. Okay, so you form these precipitates, which is look over here. Okay, so this is from the phenol groups. Same thing, it can react. So phenol as well as the molecule with the metal group directly attached to the carbon bearing the OH group, it will form this isotherm yellow precipitates. So it looks like this. Okay, so this is the precipitates. So you see over here down there at the bottom, that is the precipitates. So some of them is being suspended over here. Yeah, that's why I mentioned that it's really depending on the how much it has been formed. If you put a lot of reagent in there and you have a lot of your molecule to react, then there will be more precipitates being formed. Okay, if there's only a little bit formed, okay, then you only see some dispersion of the yellow precipitate in the solution. You won't see a lot at the bottom. Yeah. Okay, the moment you can see, the more you add in there, the more molecule you have in there, then you form a thicker or more obvious yellow precipitates at the bottom of your test tube. Okay, so this is the negative test. Yeah, you don't see anything. Okay, so this is the isotherm test. Lucas test. Okay, the next test is the what we call the Lucas test. Okay, this test can be used to differentiate between water-soluble primary, secondary, and tertiary alcohol. Yeah, so it can differentiate. There's a whole reason why you have unknown D, C, D, and E. Okay, that's why you got three unknowns: C, D, and E. So one of them will be primary, one of them will be secondary, and another one will be tertiary. All right, so it will be reacted accordingly. Yeah. So in this case, the Lucas reagent is mixed with a zinc chloride. Okay, this is a zinc chloride in the concentrated HCl. This is a HCl usually used as a catalyst. Addition of the reagent to the tertiary alcohol causes an immediate formation of insoluble white layer. Okay, if it's a tertiary alcohol. A secondary alcohol reacts slowly. Okay, only give a white layer after slight heating. So you need some heating to promote the reaction here. All right. So usually what happens, right, is that you will add all this reagent to your primary, secondary, and alcohol. Okay. Or you add all into the unknown C, D, and D in the test tube. Then after that, these will be observed, and then after that, heat in the water bath. So the test tube will be put inside the water bath. A water bath is where inside they have hot liquid, the water. Okay, the water bath they have water, and then they will heat up to I think if it's not mistaken about 50-60 degrees Celsius. Okay, actually if it's boiling, then it will be more hot. Yeah. Okay, about maybe 90 degrees Celsius. Then the test tube will be put, the test tube will be put inside there. Okay, after 5 minutes you observe, after 10 minutes you observe again. Those that you observe less than 5 minutes with the insoluble, okay, look exactly like this. Okay, if you see a white layer, then you know that it's a tertiary alcohol. Okay, if you see slightly cloudy, then it's a secondary. If you see clear one, then it's primary. Because primary alcohol, you can see from here, there is no reaction. All right, so this is the Lucas test, able to differentiate between a primary, secondary, and tertiary. Actually, right, sometimes, right, you will be asking me, sir, why don't I just do one test, then I can determine what it is. It's possible one test can determine, but in this case, we are going to learn a few different tests, okay? With multiple observations, sometimes, right, you can determine very certain that this is their identity. Okay, more tests able to differentiate. If just say that you did 3 tests, and 2 of the tests, okay, shows that what is the observation, and these 2 observation is it shows that this is alkene, not alkene, is a secondary alcohol. Then you can be very determined. Even though one experiments, right, maybe it doesn't show very conclusive, but with 2 of them show conclusive evidence, then you can determine that it is a secondary alcohol. Okay, for example, yeah. Okay, that's why multiple tests, multiple different tests, yeah, sometimes is better than just one single test. All right, any questions for Lucas test?
No.
No, yeah. Okay. The last one. The last one is a chromic test. All right, chromic test is able to distinguish between primary and secondary alcohol from tertiary. Okay, so you can see this one just now is secondary and tertiary differentiate from primary. Now is primary, secondary differentiate from tertiary. Okay, dichromic solution is able to oxidize primary alcohol to carboxylic acid, secondary alcohol to ketone. Okay, actually this primary alcohol, right? Okay, for primary alcohol, actually it will be oxidized first to aldehyde, then OD to carboxylic acid. Yeah. Okay, the end result will be carboxylic acid. Okay, because the secondary alcohol can only be oxidized to ketones. Okay, cannot no more further reaction from carboxylic acid. Yeah. Okay, you have learned this. I have briefly described this in the alcohol, the chapter. Yeah. Okay, so in this case, what happens is that if it's be able to oxidize to either a carboxylic acid or ketones, what happens is that the brown red color, okay, of the chromic solutions will be turned from the brown red to blue green. Okay, to blue green. Okay, look exactly like this. Blue green. This is the original. This is the original color. Okay, brown red. So if it's a primary, secondary alcohol, okay, it can be oxidized. And then what happens is that it can reduce the brown red color to blue-green color. Okay, because the molecule is different already. You see over here, the molecule different already. This is a H2CrO4. This is Cr2. Okay, this is Cr2SO4. Okay, then bracket 3. All right, and because of the different molecule structure, that's why it absorbs the color differently. That's why it can change from a brown red to the blue green. If it didn't react, in this case, you see the tertiary alcohol, it doesn't no reaction. So the H2CrO4 will remain as brown red color, like this one. Okay. For the phenol, right, you can see something different here more. If you got test, you got phenol. Phenol is another reagent that is not being used in this lab, all right? But if you got phenol, then you can see some terry masses here at the bottom of the test tube, brown terry masses, like sisa like that, a brown color sisa at the bottom of the test tube. Okay. Okay. Brown color of the precipitates. Okay. Sisa is a Malay terminology for precipitates. Yeah. So you will see a brown precipitates at the bottom of the test tube. Yeah. If it's a phenol. Okay. Any questions? Okay.
Just question for the last one. I don't think just based on this test alone, you can't differentiate one and two, primary and secondary. But is there any other way to after the test to differentiate carboxylic acids and
That's why.
ketones from
No, that's why we have multiple. That's why the same reagent, right? The primary alcohol, secondary alcohol, and the tertiary, we have do all these three tests: isoform, Lucas test, and chromic test. Okay.
okay.
So that's
So
how
it's
I
just
mentioned. Yeah, that's why I mentioned that we don't use just one test. We use three tests to ascertain that their identity.
yep, I
Okay.
get it.
Can I? Okay,
All right,
good.
thank you.
Any more questions? Okay, that's why you see over down here. This is basically the observation. Yeah. Okay, so based on this observation, then you can come up with your conclusion. Okay. Okay, do you want this slide? If you want this slide, I can attach into the Times portal.
Yes.
Yes, yeah. Okay, good. Okay.
Dr. Ben, can you attach the video recording of today as well?
Can.
Thank you.
Yeah, after that, we'll attach together. Okay. Before we, I think that's it for today. But before we end, please do this. What we call the camps. Okay. Okay, today the camps, yeah. The camps is L44EE4. L44EE4. So how's your morning? Good? My morning is good. How's yours? Daniel, yeah. You are in Dubai, right? So now it's like what? Like 5 a.m. is it? So the birds are still sleeping. Good. So now you become an early person. This too early. You can go back to sleep after this. Okay, still got how many people haven't do the attendance? Two more, yeah. Two more. More like a Batman, is it? Who is the two more person that haven't do the camps? Two more students. Where is it? Teo Hao Ping. You haven't do yet? Teo Hao Ping.
Other Ben, the report is not handwritten, right?
You can type.
Okay. Because if handwritten later you don't understand.
Actually can also if you can combine between type and also draw because in the report there is a drawing as well.
Yeah.
So you see though, if it's handwritten, maybe it's easier for you. I'm not sure.
Okay.
Depends.
Doctor, I have a question.
Mm.
Hello?
I have a question.
Yes, yes. Can you? Yeah, you can ask.
So since we're not doing the experiment today, we're just gonna make our results based on the information we're given earlier, right?
Yes, correct. Here.
Oh, okay.
So what happened is that later on I will attach more, okay, the video. Okay, where is it? Oh, this later on. Later on, this is the result. You see over here. Later on, I will attach the video, which is this recording, and also the what we call the PowerPoint presentation over here. Okay, you know, attach over here together in this section. Then you start doing it. Okay, don't wait. Yeah, later you've forgotten about our lesson today. Please do it first. Then after that, you wait until together with the practical 5, you scan together into one file. Okay, the reason why I ask you to wait is so that you can scan into one file and then submit over here. See here, this link here. Okay, later I will put a big link here. Click here, okay, to submit.
Sir, the drawing is okay if it's digital.
You can do digital, you can.
Oh, okay, thank you.
Can. If you can do it, then by all means, because some people it's difficult to do it digitally because the mouse sometimes is difficult to control. For me, I got the pen. That's why it's easier, not easier. It's easier for me. Okay. 2 more person. Who is that? Teo Hao Ping. Can you please mark your attendance? Teo Hao Ping. I don't see your name. Who else? Who else is one more? Yeah. Nick, do you see who else is haven't marked the attendance? Still got 5 more minutes.
Dr. Ben,
Always, yeah. Can you check whether your name is there? Yep, yep. Oh.
So like for the practical report, do you have to make a cover page?
No need. Just a simple, just write out. That's it. I look at the content. Yeah, I look at the content.
Oh, all right.
Make sure your file name, yeah, your file contains your name as well as your ID. Yeah. Maybe you write there practical submission. Yeah. So that I know, so I can identify you directly from the file name. Yeah. Because if I don't see your file name, usually I click on the file name easier. And sometimes you can also write inside your name and the ID. Make sure you write inside the document as well, your name and your ID, so that I can know that this is from who. Because sometimes students submit to me, I cannot find. The file name doesn't have name and inside doesn't have name as well. So I cannot identify.
So with the file name as our name.
Can also, and also inside the document. Yeah.
And also as
one more.
The discussion here, we just write there and handwriting here, the space here given.
Sorry? Yes. You just copy that into it. The observation. This observation, right?
I mean the discussion. Have all the spaces given here. Yeah.
Oh, you can have more. Yeah, if you want to write a full page, yeah, by all means. Yeah, there's no limit. Yeah. Okay, who is that one person?
Oh no, Dr. Ben.
Lama. Why? Who else?
Probably fell asleep first.
Sorry?
Watching.
Fall asleep already.
Yeah, maybe.
Yeah.
Collapse already. Not fainted, right? Who? It's closing already. Then that's it. I'm not going to remark the attendance.
Oh, sorry, me.
Ayo, our Clement Koko ka?
Yo, Clement.
Sorry.
Wait. Fall asleep.
No, my bad.
Okay, maybe went to breakfast with the parents then. Clement, you're eating your ice cream, is it?
No ice cream in the morning, sir. No ice cream.
Okay, it's
L44
okay. I still got 2 more minutes.
L44E44, right?
Yeah, L44E4. You still got less than 2 minutes.
Okay. Done.
Done. Okay, finally.
Okay. Sorry,
Yeah,
my bad.
everyone waiting for you to leave the class.
Oh.
Okay, so that's it, yeah. Any more last final questions?
No, Dr. Ben, everything good.
Oh yeah, everything good, yeah. So remember to submit, yeah. Okay, no submission, 25% all gone, yeah. Okay, please remember to submit, yeah. By 2nd of November, yeah. Practical 4 and 5 together. Okay.
Wait, so it's
Dr. Ben,
13th of November or 2nd of November?
13, sorry. How come I got so many? Oh, no, sorry. 2nd November is our next one. I give you extra time. 13 November.
Okay, understand.
Okay, sorry about that. Submit by 13 November, yeah, because how to say, yeah, this one, the submission, over here, the submission, yeah, is the time lock, yeah, which means that if you pass 13 of November, then you wouldn't be able to submit anymore, yeah. So be careful, yeah. If not mistaken, it is until midnight of November.
Okay, Dr. Ben.
Which means that so until before it reaches 14 November lah, then you can submit. Okay. Before that, you can submit. After that, when the moment it touches 14 November, then you cannot submit. Okay. So please take note of that.
didn't you
We
mention?
have Technology 101 class tomorrow. No. Same thing. You watch the video first. Okay, I think I have opened up already. So you watch the video, then we'll discuss on Friday. Okay, for the rest of it. Yeah. So you watch the video first, online video for Currently 101. Yeah, you watch the video, then we will discuss on Friday morning.
Dr. Ben, you did mention something about some poster assignment in the beginning.
Yes, poster assignment. I will brief you guys on Wednesday.
Okay, all right.
The poster is here. Because I don't want to discuss so early soon because you guys still haven't finished your you haven't submit your what we call it the mini project. Yeah, the mini project, this one. How is it going with the mini project? It should be quite simple, yeah. It should be quite simple, yeah. So make sure, yeah, one of the team leader, please submit to me, yeah, through the email, yeah. The instruction is here, yeah. Each group member, please nominate a group member to submit your group mini project. Make sure you send to my correct email address. Okay, title Organic Chem Mini Project. Which group? Group 1, Group 2, Group 3, yeah. Before this date, yeah. Make sure, yeah. Can, yeah? Okay. The moment I receive it, you wait for 1 or 2 days. Okay. Usually, immediately, within the day, right? If you submit to me, then I will tell you receive with thanks, yeah. If you did not see I send you receive with thanks, then check with me, yeah. Okay. If the second day, if you submit like today, if by tomorrow I haven't write to you receive with thanks, okay, then you need to text me or maybe you email to me again, yeah. Okay, because my email inbox, right, sometimes got problems, yeah. It pushes to my email address, to my mailbox, sometimes a bit delay, either a bit delay or maybe it didn't go through, yeah, because you write my email address wrongly, yeah. All right. Okay, if there's no questions, this is the one that I told you. This one, the poster, I will open that. And still hidden in the inside the times, yeah. I will open up after Wednesday lah. You finish your mini project first. Okay. Can?
Doctor.
Yes.
This class until what time?
11.
Now it's 9.
Yeah.
Huh? End already?
Yeah, done already. Who is it? Clement.
Oh, okay.
Clement, are you okay?
No, I see the time. I'm a bit confused. I thought you're still teaching. Okay, now my
No
nothing.
lah.
Okay.
Because in the lab, right? In the lab, then you have to wait for reaction, ma. Just now, no need to
Oh,
wait for reaction, ma. I explain, ma.
wow. Okay.
And, okay. Okay, so I will see you for those who is current G101. I will see you on Friday. For organic chem, I will see you on Wednesday morning. Yeah. Okay. All right. All right.
Okay,
See
Dr.
you.
Ben.
All right.
All right. Thank you, Dr. Ben.
Bye.
Thank you, Dr.
Okay.
Ben.
Thank you,
See you
Dr.
on
Ben.
See
Wednesday.
you. See
See you on
you.
Wednesday.
Thank you, Dr. Ben.
Thank you.
Yeah, Dr. Ben.
Dr. Ben.